Hello everyone, my name is Dr. John Gross and welcome to another GIS lecture video. This lecture video is going to be the second video in our lecture series talking about what GIS is, why it's helpful, and sort of how we can fit it into the larger processes of the real world. So this video, I want to actually take a sidestep a little bit and focus in on what we mean when we say spatial data. Because when we talk about GIS, we often talk about it in relation to this thing called spatial data without ever actually talking about what spatial data actually is, right? And so if we think about data, right? If we think about data, in everyday life, right? We might think of things like, oh, how tall a person is, right? That's a piece of data. Or maybe we think about, a medical study where you have a bunch of patients that have different medical records, right? Those medical records are data. But what makes something specifically or uniquely spatial data? Spatial data is data that has an explicit where or a specific location, right? So spatial data is data that has a specific quote where. Or when I say where, what I mean is a location, right? Now, the benefit of this is that it is actually relatively straightforward to take a lot of what is traditionally non-spatial data and give it a location. And in fact, there are entire chapters of textbooks, and there's going to be weeks of this course that are going to be focused on doing exactly that, taking things that are traditionally non-spatial and making them spatial by attaching them to a location. So what do I mean when I say location? Well, traditionally, right, location, right, is typically described as a location in terms of latitude and longitude, right? And we're going to talk about that extensively in the next lecture series, right? But you can also have location as an address, right? So for example, 42 Maple Street, New York City, blah, 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 right? That is a location, right? We know where that is on a map. You can also have it through what's called meets and bounds. This is known as the public land survey system. And with meets, sorry, that's M-E-T. Let me just erase that. It's M-E-T-E-S. Meets and bounds, or the public land survey system. And the way this works, in case you're not familiar with it, is you have a defined starting point, and then you describe distances and directions from that starting point to get to the end point. So an address, you give, it's similar to an address actually in a lot of ways. But you have a defined starting point, and then you sort of describe your way along a path to get to the end point. That's meets and bounds. And then finally, right, and we'll talk about this in detail later, is we can take a latitude and longitude, which is the three-dimensional globe, and we can convert that into an X and a Y, or an easting and a northing, or whatever units you want to use for this, on a two-dimensional surface, right? So we have these sort of four different ways that we can describe location. By and large, GIS focuses almost exclusively on this first one here, latitude and longitude, and then being converted into, X and Y for 2D. But we do have other ways of describing location for spatial data. Right, your address for your house, right? Your house is a spatial data point because it has a location being described as an address. If we go through old parcel records, so that's the outlines of properties, right? A lot of properties are actually described in meets and bounds with a specific set starting point, right? Those are all the different ways that we can describe location. And when we have location, right, any information that we have associated with that location becomes spatial data. Okay. So again, just to recap here, right, when we talk about spatial data, what we're talking about is specifically things that have locations. And we can describe location through latitude and longitude for 3 dimensions on a globe. We can describe latitude and we can take that latitude and longitude, we can convert it into X and Y or eastings and northings on a 2-dimensional map. We can describe locations with addresses. And then we can also use the meets and bounds or the public land survey system, which is a way of having a set start point that we then work out from using distances and directions. Now, again, most of what we're going to be dealing with practically is going to be this X and Y or this latitude and longitude. And in fact, we're going to talk about ways that we can actually convert addresses and meets and bounds both into X's and Y's. Addresses through something called geocoding, and meets and bounds through a process called COGO, where we take the starting point and we actually trace along the path and then record the endpoint as a X and Y or latitude and longitude. But these are all different ways that we have in the past and still continue to record locations. So hopefully this makes sense. And as always, if you have any questions, please reach out. Thank you.